Cool. Can you see my screen?
Yep.
Awesome. Okay, I'm going to be a bit technical today at points, so I will do my best to monitor the chat, but feel free to interrupt me at any point and stop me and ask me questions live, and I also will have some time for questions at the end. So we are building Arbitrum, and we say solve scaling without compromise. And I'm fortunate actually to go after Kevin, because Kevin did a really amazing job motivating the problem, which is the same problem that we're working to solve in Arbitrum. So hopefully you should have some background. And without compromise, I mean, without compromising the things that Kevin was mentioning regarding centralization, right? Tending towards centralization by just increasing parameters and requiring larger and larger nodes without compromising on security. And these are core principles that we have. And so Arbitrum is a layer 2 that builds on the security of Ethereum and is able to scale significantly in a very meaningful way and without making any of those compromises that some other solutions have to make. So who we are, well, we're quite a larger team now, but the three founders are myself, Ed Felton, who's a longtime professor at Princeton University before joining the company full-time a few years back, and Harry Kolodner, who's our CTO, is also a PhD student with me at Princeton, and that's where the project started. It was an academic project at Princeton, and where I was a PhD student and Ed was a professor and Harry was a PhD student, and started off as an undergraduate seminar. If you go back, if you look on YouTube and type in Arbitrum and look for the earliest video, you'll find a video from 2015, which is the first, I think, public record of Arbitrum. It actually goes back a year or two prior, in Ed's head at least. The interesting thing about the data of that video is it predates the launch of Ethereum by about 6 months. So we've been thinking about scaling smart contracts for quite a while. And the reason is, it was clear to us that one of two things is true. Either smart contracts technology is going to go away, or the demand is going to be so high that the current infrastructure can't support it. And we believed that the second one was true. We didn't think this was going anywhere. We thought quite the opposite. The demand was going to get higher and higher and higher. And we started building quite early. And the company Offchain Labs was founded in 2018 when we spun this out into a commercial context. But anyway, these are the three founders. We have a larger team today, but still a pretty small team. But maybe one of you will join us and it'll become a little bit larger. So Arbitrum is a Rollup, and what does Arbitrum provide you at a very high level? Cheap transactions, so no expensive cryptography. We don't rely on some of the more expensive cryptography you'll see in like zero-knowledge rollups. No on-chain re-execution. Even when there's a dispute, you don't have to re-execute transactions on chain and rerun your transactions on chain. We're able to basically have a minimum layer 1 footprint. Layer 1, by layer 1, we mean Ethereum, which means we can do a lot off chain and only do very, very little on Ethereum. So what that means is you basically utilize Ethereum's limited capacity better. We get more bang for our buck. We get more mileage on the same amount of gas, literally, because we're able to basically compress and put only a limited amount of data on Ethereum and go a whole lot further. We're fully trustless. Security is rooted in Ethereum, and we have our interactive fraud proofs, which allow Ethereum to verify essentially the correctness of the state and the outputs of the Arbitrum chain. And we're drop-in compatible with Ethereum. So we have full EVM support, one-click porting. You deploy your contracts, and the principle that we've been operating on is, and this is the principle that works today, and this is, if it works on Ethereum, it will work on Arbitrum. And that's why, we have, and I'll show soon, hundreds of projects that are building on us. And it's really, of course, we give great support to all the projects building on us, but really it's self-serve, because most of these Ethereum developers have their code that already works in Ethereum, and it just works out of the box in Arbitrum without any additional changes necessary in most cases. And yeah, it works with all existing languages and tooling on Ethereum, and we'll get a lot more into that in more detail on how we do that. But this is the very, very high level of what we do. Oh, getting ahead of myself there. So Arbitrum 1 is live on MAINNET, and just to speak about, clarify the jargon here. Offchain Labs is the company, Arbitrum is our technology, and our mainnet chain is Arbitrum 1. And the reason why Arbitrum 1 has a different name than, say, Arbitrum is because we do envision a world in which there are potentially multiple Arbitrum chains. Indeed, Reddit is partnering with us, and they will launch their own Arbitrum instance. So Arbitrum 1, though, is the sort of DeFi chain today that has most of the usage and has most of the apps. Many of the top apps on Ethereum are either already live or building on us. And some quick stats. These are from earlier in the week, so probably a little bit stale. We have greater than $2.8 billion in TVL on the platform. Different sites report this slightly differently, but if you add up all the bridges, the various bridges, that's the value that at least that I got when I summed them up. We have over 100 integrations, live apps, and infrastructure projects on Arbitrum, and many more building. We've done greater than 2.6 million transactions. 235,000 user accounts have interacted on Arbitrum, and greater than 15,000 contracts deployed. And the nice thing about Arbitrum is it's live today. This is not, you don't need our permission to deploy on the platform. We are in beta mode, which means we still have some administrative controls on the platform for security reasons, but it's fully live and permissionless in the sense that users can interact, deploy contracts, interact with your favorite apps, and it's fully live today. And we had, very liquid, very liquid markets on Arbitrum as well. To give you some examples, and this was pulled this morning actually. So from DeFi Llama, some really some of your, it's interesting. It's some of the DeFi protocols, which you probably know and recognize from Ethereum. Some new names here that aren't on Ethereum, but made an Arbitrum debut. But these are just the top 10 on DeFi Llama, but really, really liquid markets and a really blossoming ecosystem in Arbitrum. And it's only the beginning. We've opened up our mainnet on August 31st. So just about 50 days in. And, we're already seeing projects are, having very nice ecosystem building and liquidity in Arbitrum. And we only expect that to continue building over time. I'll just briefly show the Arbitrum portal. I showed it, but if you can, this is portal.arbitrum.one, and you can scroll through that and see the many apps that are already live on our platform, and the list is growing every day. So let's zoom out for a second and talk, or zoom in for a second, I should say, and talk about the tech of Arbitrum and how it works. So the big picture, the overview of the tech is you have an inbox, and these are where transactions are sent to Arbitrum, and the inbox sits on the Ethereum chain. So all Arbitrum data, all Arbitrum transactions are posted on Ethereum. They get posted in the inbox. And then you can think of a transaction of having sort of two different pieces. There's the bits of the transactions, like the zeros and ones, the data, that's what gets posted on chain. But then there's the instructions, like what are you supposed to do? The transaction might say, hey, add these two numbers, compute this, store this. And so the storage and the execution environment is moved to layer 2 and creates this chain state. And the chain state can have some outputs as well. You can withdraw back to layer 1, for example, would be an output. So transactions come in on Ethereum. They are posted to Ethereum. They describe some operations that should be done. Those are done in layer 2. Layer 2 operates as its own chain. It's built on Ethereum, secured by Ethereum, but it operates as its own blockchain. And like when you're using MetaMask, for example, you would add the Arbitrum chain, and this is true of all rollups. And then you have outputs of that chain, and the outputs are posted back to Ethereum. And Ethereum will, as we'll see, can verify the correctness of the chain state. Because fundamentally, what we want in a rollup, we want a chain that is correct and gets its security from Ethereum. And in order to get the security from Ethereum, you have to have Ethereum vouch not only for the correctness of what happens on layer 1, but also for the correctness of what happens on layer 2. And we'll see that's one of the core properties of a rollup, which we'll discuss how we do in Arbitrum today. So some big questions when trying to understand how rollups work is who keeps track of the inbox and the chain state? How do we ensure the chain state and outputs are correct, right? That was what I was getting at. We need Ethereum to verify its correctness. How is that done? How do we prove the correctness from Ethereum to Ethereum? And how do we step in if something is incorrect and make sure that it gets corrected? How do users interact with the system? And how are ETH and tokens transferred in and out in Arbitrum? And those will be the ones that we cover today. And hopefully after this presentation, you'll have some better idea of how it works and answers to all these questions. So the basics of a rollup, as I was started saying before, all transaction data is posted on Ethereum layer 1. Execution and storage are off Ethereum layer 1. So the transaction data, again, that's the zeros and ones of the transaction. That's the actual bits of the transaction that gets posted on chain. But then all the instructions, they say, hey, compute this, add this, store this, that happens off chain. And that happens in Arbitrum and is done by Arbitrum validators. Notice though, that since all the transaction data is posted on chain, anyone can just from reading an Ethereum chain, sync an Arbitrum node and catch up and do all that execution and storage. So basically what's stored in Ethereum is a compressed version that allows you to have the full state of the chain. What happens on layer 2 is the decompressed version that actually builds up the storage tree and does the execution. And then after the execution happens, we prove correctness of layer 2 to layer 1. So we say, hey, Ethereum, we did all this computation inside the Arbitrum chain, and this is the result. And we post that back to layer 1. And in optimistic rollups like Arbitrum, we do this via fraud proofs. So they optimistically, and that's where the name comes from, optimistically post to Ethereum without a proof at all and say, hey, Ethereum, this is the state of layer 2. This is the correct state, but we don't give any proof there at all. Instead, we open up a window of time, typically 1 week, where anyone can come and say, hey, that's wrong. And we will give you a fraud proof to that instance. And Arbitrum's secret sauce, the thing that Arbitrum pioneered, is interactive fraud proofs that take multiple rounds. We'll see how those work. And that was basically what allowed Arbitrum to have the EVM compatibility that it has today. Because interactive fraud proofs, as we'll see, are super, super flexible and super powerful. And just to flash back to the previous talk, I know Kevin mentioned that Optimism is moving over to OVM 2.0, and I believe this is the shift that they are making now. They're moving over from their historic single round fraud proofs to the interactive fraud proofs that we have in Arbitrum. And it's secured by Ethereum contracts. What that means is that Ethereum contracts referee this entire process, right? So if something goes wrong, it's the Ethereum contracts that you post the fraud proofs to. So you post the result to Ethereum and someone else can challenge and post a challenge to Ethereum. And ultimately, an Ethereum smart contract is going to mediate this dispute and decide what is whether the updated state is accepted or not, and who's basically lying in the protocol. So it's secured by Ethereum contracts and therefore gets the security of Ethereum. So it has this really cool property where all we put on chain in the happy case is the transaction data. We take everything else off chain, but we're able to, via our interactive fraud proofs, have Ethereum vouch for the correctness. And Ethereum can now vouch for the correctness of Arbitrum. So even though we're doing much, much more execution that's available in the Ethereum chain, we're getting Ethereum to vouch for its correctness. And that's how we derive the security of Ethereum and scale at the same time. So let's talk about the Rollup Protocol and what it looks like. And here, each one of these are supposed to be blocks. So you have 90, 91, 92, these are blocks. And the ones with checks, these are blocks that have been accepted by the system. And so imagine, for example, someone posted the block 90 and then no one challenged it and a week expired and then the system accepted it. So when that happens, the block is called confirmed. And then you continue building blocks. Even before a block's confirmed, you don't want to wait a week to build a new block because, until it's confirmed. So the state of the system continues to grow. And that's what these question mark blocks are. These are blocks that have been posted and you can continue building on one another. You see 94 builds on 93, even though 93 is not yet confirmed, and that's fine. And you continue building on one another. But here we have a dispute. So you have Alice who says the correct block after 92 is block 93, and Bob comes in with a different block, which we'll call 95. It's not actually 95 in the sequence, but we'll call it that. And Bob says, no, actually the correct block after 92 is this 95 block. And you see it says Alice staked here and Bob staked here. Whenever, and we call these validators, Alice and Bob are validators. Whenever a validator wants to make a claim in the system, and a validator can make two types of claims. They can either say, hey, this is the correct state, like Alice posts a block or Bob posts a block, or they can challenge someone else's state and say, hey, Alice's block is wrong or Bob's block is wrong. And here Alice and Bob are implicitly challenging each other because they're both posting a block 90 after 92 and they're not agreeing with the other. So essentially you have a fork. You have Alice's fork and Bob's fork. And we say they staked because whenever you want to speak up in the system, you have to put down a stake. And the idea is if it turns out you're lying, you'll lose the stake. And critically, the stake isn't responsible for the correctness of the system. The stake just is, you can think of it almost as a protection against like spam and DOSing, where you don't want people just posting wrong information. So you want to have them to have an incentive that they'll lose a lot of money essentially if they make the wrong claim in the system. But here you have Alice and Bob, and that's why in the happy case of the system, we don't expect there to be false claims because those are significantly deterred by economics. But if there is a false claim, correctness is guaranteed just by the protocol itself and doesn't rely on any economic guarantees. So Alice staked here and Bob staked here. So now what do we do? So we have how does Ethereum decide which block to confirm? Does it confirm 93? Does it confirm 95? We don't want to have a fork, so it has to basically confirm one or the other. And how does Ethereum decide? I see there's a question in the chat. So great question. So do we use the stake to compensate the honest challenger for the gas fee? The answer is right now, that's not what we do. But right now, we just basically at Offchain Labs take the role of what we call the honest validator, and we post the happy state, and anyone else can do it, but they don't have to. If someone disagrees with us, then they can challenge us, and then they can make a whole lot of money. Again, right now the system is in control. It's a fraud-proof mechanism. Completely works, but we have whitelist for validators. But in the full system, essentially anyone can disagree with the state. But in the happy case, we're happy to basically pay the gas fee to post what we believe is the correct state, and anyone can challenge us if they don't. So the answer is no, we don't, but we also don't require anyone to do that, although of course they can. So here, Alice and Bob have both staked, and then the question is, how do we figure out who's right, Alice or Bob? So how are disputes resolved? And again, all inputs are posted directly to Ethereum. I'll repeat that because that's important. Because if we didn't even have, if we didn't have agreement on what the inputs are, it would be very, very difficult to resolve the dispute. But since everyone can look at Ethereum, and in particular, Ethereum records what the inputs are, everything after that is deterministic. The execution on chain is deterministic, and because by design our virtual machine is deterministic. So once you agree with the inputs on chain, basically everything is deterministic, and Ethereum can resolve it. But if there was if there was uncertainty about the data, we'd have a much harder to solve problem, because we're not only disagreeing about the outputs, we're also disagreeing about the inputs. So critically, it's important that all inputs are posted directly to Ethereum. And from there, Alice and Bob in our picture are really disagreeing about something that can be deterministically determined. Validators make bonded claims about execution. As mentioned, they put down a bond and say, hey, this is the correct state, or hey, I challenge yours, it's incorrect. Invalid claims can be challenged by anyone. Again, we call these people validators, but because the validator role it will be a permissionless role, anyone can do that. So that's where the system, validators can be anyone, it can be you. Interactive challenge to narrow down the dispute. And that's our process, which is basically, for those of you who have a computer science background, we do a binary search. We interactively, and I'll show that in much more detail in just a moment, but we interactively narrow down the dispute and say, hey, Alice and Bob are disagreeing about a large thing. Maybe they say, hey, Alice says, I executed the virtual machine for 1,000,000 steps, and this is the result. And Bob says, no, that's not the result. So now they're arguing about 1,000,000 steps of computation, but via an interactive challenge, we narrow that down to just a small step. And then once we're down to one step, we have what we call a one-step proof to declare a winner. And we'll see how that works in much more detail in this diagram. So somebody posted, let's say Alice posted, say, hey, the start state was, we'll call H of S0. H here is a hash. So it's just, you post a digest of the state on chain. Again, all the input data is posted in full on chain. But when you report back to Ethereum, you just post a hash to say, this is the hash of the state. And you also post the outputs. See, there's money, and there's an envelope. So whatever messages or withdrawals are posted to Ethereum, those are part of the claim. So Alice says, hey, I executed the machine n steps, and it ended up at this state. It started off at this state and ended off at this state. And critically, everyone agrees with the start state. That's because that was the last confirmed state, which everyone agreed upon. And they're only disagreeing about now this final state. So Alice says, I executed the machine n steps. This is the final hash of the state. These are the outputs. And Bob says, no, that's wrong. So then what Alice does is she goes ahead and says, okay, I'll post the middle state. And this is why it's a binary search. You can see where this is going. This is my state in the middle. And fundamentally, since they all agreed in the beginning state, they disagreed at the end state, they must have disagreed. There must be one step where their disagreement started. Maybe it was the first step, maybe it was the last step. But the question Bob has to answer is, do I agree with the middle state? And if Bob agrees with the middle state, then he knows that something went wrong over here. If Bob disagrees with this middle state, then we know that something went wrong over here. We're looking for the first point of disagreement, the first step, the very first step. And when I say step, I'm talking about steps of the virtual machine. So really very, very small units. So here Bob says, well, I agree with this middle state actually, but I disagree with this piece. So now we've narrowed down the dispute of n steps. to a dispute of n over 2 steps. And they repeat this process again, and now we've narrowed it down to a dispute over n over 4 steps. And now in a logarithmic number of rounds, we narrow down the dispute to a single step of the virtual machine. And then all we need to do is run just one step of the virtual machine on chain, and that's what we call a one-step proof. So we take a disagreement about a lot of information, and we condense it down to a disagreement about just one step of execution, which is really, really easily resolved on chain. And this is the beauty of interactive fraud proofs, which we've been working on an Arbitrum for a while. And the reason why they're so powerful is the dispute process is, other than the number of rounds, the actual dispute process, the amount of work you have to do in the one-step proof is not dependent on the number of steps that you have to take, the number of steps that you're disputing about. So you can, for example, make a claim about a lot of information, and you can just condense that very, very effectively. And this is important because it allows us to do transactions that are much, much larger than what Ethereum would allow. We can have transactions that, say, use much more gas than Ethereum would allow, or have contract deployments that are much larger than the Ethereum allowed limit. And the reason is because we don't have to ever re-execute this on chain. Even in a dispute, we don't have to re-execute this on chain. In the OVM, for example, not the OVM 2.0, in the OVM, their model was, this is the Optimism current model, that we re-execute transactions on chain, and then your transactions are limited to what can be done on chain in a single block. But since with interactive fraud proofs, this allows us to separate and break the dispute process from the end. So we can do transactions, and in fact, our disputes are not only over transactions, they can be over hours long of computation, and we only need to ever dispute one step on the machine. Of course, the number of rounds increases of this dispute process, but it's still efficiently resolved on chain. I should also mention, in practice, our dispute process, this is it's really a much more optimized version of what I'm showing here. Instead of doing a binary search, we do like a k-ary search, where k is like 100 steps at a time, and some other really, really neat optimizations. But this is the core idea of how interactive fraud proofs work. They take a disagreement about a large amount of computation and turn it to a disagreement about a small amount of computation that can be effectively resolved on chain. So interactive fraud proving is awesome. It's hyper efficient in the optimistic case. In the optimistic case, all we need to prove is this one state. Alice just says, hey, this is the state. And if nobody challenges, you have the clock up here. If the week goes by and no one challenges, it's just accepted. And even in the dispute case, there are minimal L1 costs, because your full transaction never runs at L1. All you're doing is this back and forth rounds where you're basically pointing left or right and posting a hash. Very, very efficient, not very much data on chain, small transactions. And you can do much better in terms of gas and contract size limits, because we're not limited by Ethereum. Since we never have to re-execute on chain, aren't subject to Ethereum's limits, and we can break out of them in the individual transaction as well as in the aggregate. And also, it allows us for a lot of flexibility in our implementation and in our fraud proofs, which I'll talk about a lot, of some really nice features we're bringing in NITRO, which will allow us to basically keep the system working exactly as is, but swap out some components and make it even better and even more awesome. So the L2 view. This is like what the system looks like if you're a user using layer 2. So you talk to an Arbitrum node, and the Arbitrum node speak the exact Ethereum API. So you just talk to an Arbitrum node exactly as you would Ethereum, and you can use that to deploy contracts, to interact with contracts. And you have EVM contracts that we basically we have full EVM support. In fact, Arbitrum today has EVM support on the bytecode level. We are the only optimistic rollup today that has EVM support on the bytecode level, which means that our bytecode, we take EVM bytecode directly. And that means that you can deploy contracts in any EVM language. And under the hood, how we do that currently is, so users talk to the Arbitrum node, and they talk to it, again, using a standard Ethereum API. They can deploy EVM contracts, and there's EVM compatibility because, again, we accept EVM bytecode. So they deploy contracts or transact in Solidity or Viper, whatever EVM language, whatever works in Ethereum works in Arbitrum. And then we have this layer ArbOS. So under the hood today, we're not actually running EVM on our chain directly. We're running something called AVM, which is the Arbitrum virtual machine. But we have the Arbitrum operating system, which runs trustlessly and basically does the transformation from EVM to AVM. So the interface that users get is EVM bytecode, but what we're actually executing and what we're actually, say, disputing on layer 1 is actually AVM. And the link that gives us EVM compatibility is ArbOS, which is our operating system. So nodes provide a standard JSON RPC endpoint. And because of that, we're compatible with most standard Ethereum tooling like MetaMask, Hard Hat, etc. It just works out of the box with Arbitrum. And again, this is all not theoretical. It works today. You can use it today. And 15,000 plus contracts have already been deployed, and users are, and hundreds of live dApps are using this. It's trustless because we have this role we call a validator, and the validator is important for security. But in the full system, once we remove the guardrails, anyone can take this validator role. And of course, all the code is fully complete and audited today. Users can deploy contracts using any version of Solidity or Viper. That's important, and that comes from the EVM bytecode compatibility. Some other rollups rollups differ on the spectrum. Some have their own languages and aren't trying for EVM compatibility at all. Others are trying for some form of Solidity or language level compatibility. Arbitrum really pioneered via our interactive fraud proofs the compatibility at the bytecode level, and really gives you the full Ethereum experience. And then we don't care what you can use any version of Solidity. You can, because it all compiles to EVM. We're not compatible at the language level. We're compatible at the bytecode level. So any language for EVM language automatically works on Arbitrum. And the key here is, and this is our key principle in how we design the system, is if it will run on Ethereum, it runs on Arbitrum. Arbitrum can support essentially anything that runs on Ethereum with zero or minimal, but usually zero changes. And if it's too complex for Ethereum, it might still run on Arbitrum. That's because we can support these transactions that are much larger than Ethereum. We can support contracts. Ethereum has a 24K limit on contract deployments, and we can support contracts that deploy that are larger than that. So anything that runs on Ethereum will run on Arbitrum, as well as some things that don't run on Ethereum will also be able to run on Arbitrum. ArbOS, that's the operating system, which I alluded to before. And this basically plays the role of giving us generalized, safe L1, L2 transactions. It basically plays the role of an operating system. It does things like separate user processes and transactions. It facilitates sending tokens from layer 2 to layer 1. We do things in ArbOS like transaction batching. So you don't want to, remember I said that you post your transactions to Ethereum, and that's in the Ethereum inbox, all data is posted to Ethereum. You don't actually want to post each transaction as a separate transaction to Ethereum, because that'll be too expensive, because there's some overhead for posting to Ethereum that are much larger than the cost. So what you do is instead we post transactions in batches, and ArbOS knows how to unpack a batch. We also have some innovations that allow ArbOS, like I said, to add features that are not currently available in Ethereum. We have, for example, we've worked on BLS support in ArbOS. There's no current client-side support for that, but BLS basically is this really, really efficient signature scheme that can be batched. You can batch signatures together, and one of the remaining large costs for many smart contracts application is actually putting the signature data on chain. With BLS, it allows us to batch that together and basically take n signatures and compress it down to the size of one signature. We have EVM compatibility at the bytecode level, as I said, and that's provided by ArbOS. ArbOS takes EVM bytecode and under the hood translates it to AVM, but this all happens not in the user machine, but in the Arbitrum ecosystem, so it's fully trustless. And it's also easily extensible with new transaction types and features. BLS is one example of a feature that we added via ArbOS, but you can add many, many other features as well. And you continue to be very, very flexible. So putting it together then, if you look back to the original picture we have the inbox state where you post your transactions in a compressed form on Ethereum. You post the call data. That then goes ahead. You post that EVM transactions. That then leads to a chain state. ArbOS translates the EVM to AVM. We have an AVM chain state, and then we have outputs, which we basically, these are the hash of the state of the system, as well as the withdrawals and messages that you go ahead and post those back to Ethereum, and Ethereum goes ahead and validates those and says, yes, those are correct. Or if there's a dispute, Ethereum will mediate the dispute and make sure that we agree on the chain state and the outputs. So if you squint here a little bit, you'll see a little more detail. There we go. And this is the larger picture. So before we saw part of this picture, we saw how the users interact with Arbitrum nodes, and they have the EVM experience provided by ArbOS. the Arbitrum nodes here, if you basically talk to Ethereum nodes, because again, the Arbitrum nodes have to post all the data on Ethereum, and they also want to watch for disputes on Ethereum, right? If a different validator goes ahead and posts on Ethereum an update, other validators want to watch and say, hey, I agree with that, in which case they have to do nothing, or, oh, no, that's wrong, I want to challenge that. So our users connect to Arbitrum nodes, but Arbitrum nodes in turn connect on Ethereum, because again, we're built on Ethereum, we post transactions on Ethereum, and we get the security of Ethereum, and that requires interacting with Ethereum. And to go into a little more detail on the right side here, so this is how the stack works. Remember, we have EVM contracts that give us full EVM compatibility at the bytecode level. That's provided by ArbOS. ArbOS does the translation, but the AVM architecture is actually what runs on chain. That's the Arbitrum virtual machine. So when we talk about, hey, I executed the machine n steps, and or we do a one-step proof where you run one step in the machine on chain, what we actually run on chain is the AVM, the Arbitrum virtual machine. We don't run EVM directly on chain. We run AVM. And on chain, we have the ETH bridge, which is what we basically the smart contracts that mediate the dispute process. And we have the Rollup Protocol, which is, again, the protocol that's mediated by the ETH bridge, where validators can post updates and others can challenge it. And we have the inbox and the outbox. And these are the transactions that come in. All transactions are posted into the Arbitrum inbox. And then we have the outbox, where messages are sent and output from the machine as well. You can, for example, send a message from an Arbitrum contract to an Ethereum contract. So Arbitrum NITRO. So that's what I described until now is the current state of Arbitrum, what everything looks like today. We are about to push, we announced a few weeks ago, and we are soon to push a very, very major upgrade to Arbitrum called Arbitrum NITRO. And the nicest thing about this upgrade is it will all happen seamlessly and under the hood. This is something that's been in the works for quite a while. And our development process was structured as such that it will be a completely seamless upgrade. And so the one thing about Arbitrum is it's running today, it works today, and we will make sure that deployment is not going anywhere. And so everything that we push, that we plan to push in NITRO and beyond, we plan to push seamless upgrades to that, no breaking changes. So if you're using Arbitrum today, you can continue using Arbitrum today, and we'll just continue to make it even better for you. So what is Arbitrum NITRO? Interactive fraud proofs over WebAssembly. So in the previous, WASM is like a very popular VM architecture. And previously I mentioned we were using AVM, which is a custom virtual machine that we had designed to do fraud proofs, but we actually now have a fully working fraud prover built in WASM, a standard architecture. And why is this nice? Because if you go back to this picture here before, so we were using AVM, and then we had basically an entire stack built on top of AVM that included a custom programming language and a custom node implementation. But once we have WASM, we can take a standard Ethereum client. We take Geth, which is Go Ethereum client, the Ethereum client written in Golang, and we can compile that directly to Arbitrum. So we can have the on-chain dispute process, not about the state of the AVM and the state of our custom node, but actually using the EVM Geth node. And this will still require an ArbOS component to do some of the housekeeping functionality, but that's also rewritten in Go to be really, really efficiently work with this system. So the idea is that we are basically swapping out the AVM for WASM, and this allows us to use the Geth client directly. And what does this do? So what are the benefits of this? So this is the most EVM compatible possible. Today, we're again already fully EVM compatible on the bytecode level, and we have API for the standard API equivalents with Ethereum. But there is some tooling that relies not only on the facial API, but also deeper on the internals of Geth, say. There's some tooling, say debugging tooling, that builds into the internals, and we will be able to now have internal consistency with Geth as well. And also our gas model will become identical to Ethereum. Today we have ArbiGas, which is a slightly different model. Again, it's all paid in ETH, but it's the gas accounting, the pricing per operation is a bit different because we're running a different VM. This will allow us to get exact gas pricing identical to Ethereum, which is really nice. And again, it's a seamless upgrade from the current Arbitrum 1 deployment, which means Users who don't care about this, that's fine. All they'll notice is that their costs go down. But we're not disrupting users at all with this. It's pushed as a seamless upgrade, and the chain won't be disrupted, and state won't be deleted, and everything will continue to function exactly as it is today. So it's some really, really goodies, but nothing that you have to be concerned about, or no reason not to use Arbitrum today. And it's also, it's better in every metric, basically. It uses less one-call data. We're compressing that significantly. We have more compute throughput, and also our storage costs will go down. So all this means that the cost will go down significantly. And the important thing about us is this is, we will push this upgrade when it's fully built and fully ready. Today, we have fraud proofs fully built and fully designed and ready. And when we push our Arbitrum Nitro, our fraud proofer is ready, currently complete and running in-house. It's a very mature project, but from day one, when we push this, there will be fraud proofs live in the system. And because that's really one of the most important parts of the system, making sure that it's complete. So Arbitrum Nitro is nearly there, and it will go from it will be a complete system from day one and fully designed. And so what does Arbitrum Nitro look like if we take a look back at our diagram and we apply Nitro to it? So notice here on the right, we used to have AVM here, and now we have WASM, and we still have an ArboS component, but now ArboS calls out to Geth. So we are using Geth for EVM compatibility. So EVM compatibility comes from the combination of ArboS calling out to Geth, and that's how we're able to essentially use Geth and swap out WASM. But notice the really critical thing here, back to what I was saying about a seamless upgrade, is nothing in the user interaction changes, right? The users are still using the Ethereum API, and they still have the same EVM contract support. So some developer tools will change, gas accounting will change, fees will go down, but the user experience will be completely uninterrupted. And we're basically, this is an internal upgrade that will get us some really nice features. But for all those users that are using Arbitrum today, nothing will be interrupted at all, which is one of our key principles as we built our technical roadmap. So you can learn more about Arbitrum. There's a document called Inside Arbitrum, which I have a link here. Which is just in our developer docs if you want to Google that. Join our Discord, join our community. We have an incredibly strong community and welcome people to really participate, ask questions, hang out. And we will always love to engage with you there. Twitter, you can follow us on Twitter for, every day we're making product announcements with teams that are launching on Arbitrum. Again, it's live today. It's fully deploying contracts, is fully permissionless, so anyone can do it. And we're seeing a ton of activity from really, really awesome teams and a ton of innovation. And it's super exciting for us. And lastly, which I started with and I'll end with, join our team, offchainlabs.com/careers, or you can also drop me a message. And if you are graduating senior or grad student, would love to talk to you. We don't have any official internship roles open yet for this summer. We did have several last summer, so you can definitely feel free to keep an eye out for that, or just send us your resume. We have one of those, just send us your resume. If you're not sure what role it is, you can drop that there as well. And please, we are working on some of the most important, I think, problems in Ethereum today. And we have an incredible team and are trying to grow that team. And, despite the fact that Arbitrum is live today and running and many, many users and dApps are using it, we still have a very, very deep and exciting technical roadmap. So it's still early days, and we'd love to work with you. So with that, I am happy to take any questions. Okay, I see a question in the chat here. Huge fan of Arbitrum, thank you. I am also, but I'm a little bit biased. Magic Internet Money, MIM is one of the really, really strong projects on Arbitrum, and it's really, really exciting to see all of the liquidity that it's brought across. MIM, for those who don't know, is a stablecoin project, and one of the most liquid projects on Arbitrum, or one of the most liquid tokens on Arbitrum right now. And as alluded to here in the question, much of the sushi swap volume is definitely MIM pools. I think there's a lot of MIM and Curve as well. So I know the team, and really, really think very highly of them. I'll pause here to say one of the things that we did in Arbitrum for our launch was we did this thing called a fair launch, which basically meant that we very much believe that it's not our role to choose who to be the gatekeepers and say you can deploy or not, or to really give teams an advantage. We want to really support everyone, and what that means is there are teams, for example, you could take your favorite DEX DApp category, and there are teams that are maybe number one on layer one. And maybe they'll be number one on layer two, and they probably will, but it's not our decision to do that. So we try to make a fair play, an equal playing ground for an equal playing field for all teams, where both old, existing Ethereum teams and new teams alike could come on Arbitrum and feel home there. And it's not, it's up to their execution of how they deploy on Arbitrum. And we're seeing that with a lot of projects where we have a mixture of, the biggest names on Ethereum with new projects that are launching on Arbitrum, and is excited to see it play out. But we take a very, very neutral stance. Not to say we don't help teams. We love all teams. We help them all, and we give assistance to anyone who needs it. Generally it's relatively little that's needed because we have the full EVM compatibility. But that being said, I think very, very highly of MIM, as well as many of the other projects deploying on Arbitrum. I see another question. I'm in a group of devs. We are working on a project related to L2 clients and MEV. It would be okay. Yes, you can definitely reach out to me. My Twitter DMs are open, so it's just Goldfeder on Twitter. I did some early work on MEV with Phil Diane. Wrote co-authored the paper on Flashbots 2.0. We have very exciting work on Arbitrum related to MEV. Another paper that I co-authored at my time at Cornell was about fair ordering BFT, or consensus algorithms that basically guarantee a fair ordering. And it turns out that we can use these. So one piece we didn't really focus on our tech here is the sequencer. And this is in the normal case, you would send your transactions to the sequencer, and they're the ones that batch them on chain. And the sequencer has some power in ordering. And of course, ordering power leads to MEV power. But if you can basically build a protocol that makes sure the sequencer can't reorder, you can essentially eliminate most MEV from the platform. And at Cornell, when I was there as a postdoc, I worked on a paper with Ari Jules, Mahimna Kelkar, and Fan Zhang on a fair ordering BFT protocol, or a consensus algorithm that guarantees a fair ordering. Because your typical consensus algorithm actually doesn't care about ordering at all. You could take Bitcoin or take any BFT. What you care about is agreement, right? As long as everyone agrees that these are the transactions that are in a block, or these are the messages that are agreed upon in the consensus protocol, traditional consensus is happy and satisfied. So you could completely reverse the ordering of messaging. You can randomly permute the messages, and as long as everyone agrees, typical consensus is happy. But what we designed was a protocol where you don't only have agreement on the transactions, but you also have fairness represented, of order fairness, which means transactions that were sent first should be first in the in the output as well. And this allows you to really build a sequencer that's distributed, that runs a distributed consensus in the sequencer that prevents MEV. So that's a long way. I think that's I answered. I think that was a little more than you asked for, but that's one of the MEV and fair ordering is one of the topics I'm super excited about, because it's one of these opportunities we have in layer 2 that allow us to go back and do better than layer 1, and not settle and say, let's give you the same experience as layer 1, but say, hey, how can we innovate and make this better? And I think we've landed on a very, very good solution there. So apologies for my excitement there, but definitely feel free to reach out to me. We have some incredibly exciting internal projects going on about building out fair sequencing on Arbitrum, and would be happy to see how you could participate there. Cool. Any other questions? Feel free.
Hello, can you hear me?
Yes.
Yes. My name is Huanan. Because you say you finished your postdoc in Cornell, right?
Cornell Tech, yes.
Yes. Because it's the university Cornell.
Cornell Tech, it's part of, it's on Roosevelt Island. I was associated with IC3, which is the initiative for contracts and cryptocurrencies, working with Ari Jules. Yeah.
Oh yeah, because I made mistake that maybe you are from the Cornell University. So.
No, so again, my background is, I did my undergraduate at Yeshiva University. Then I spent a year at Columbia, actually, in a master's program. Early on that year, I decided that I wanted to do my PhD. So I ended up moving to Princeton in 2013 and did my PhD there. That's where I got involved in Bitcoin and cryptocurrencies. My advisor, Arvind Narayanan, at the time was going down this exploration of Bitcoin and took me for the ride. And together with Arvind and actually Ed and some others, we actually co-authored a textbook on cryptocurrencies called Bitcoin and Cryptocurrencies Technologies, which is used in many universities, and did some early work on threshold signatures, and then and some other cryptography there. And then I did a postdoc at Cornell Tech in New York City.
Okay. Because there is another professor, because it looks you guys do a lot of this security simulation and pay more attention about this level 2 each node verify or something active. Because I'm kind of looks like you provide this mechanism for this L2. For example, because another Professor Gu, whether you're familiar with the circuit, they do the security protocol audit, something like that.
What's that professor's name?
Professor Gu.
Gunsir?
Yes, Ronghui Gu. Do you know him?
Oh no, I don't know. I'll look. If you could just type the name in the chat, I'm curious.
They do the security audit stuff in the company's circuit. Yeah, CIRC.
Interesting. Yeah, we of course work with many auditors at Arbitrum and many of the top auditors, but we're always
right. Because like the recently I meet the Boba Con. Do you know the Boba? They are based on the L2 organism too. So they also get some audit security stuff from the circuit group. So I when I check the your mechanism, it looks a lot of verifies based on this level 2 level. So my question is, for example, if normal people want to get involved about this, provide this verified node into your system, what they need to beginning, or maybe try to learn?
Yes. So today, I mean, there are many teams that are running nodes, but we don't really have support. We don't have support for the full system. We're running validators. The validators are running on the system, but we haven't opened up validation for everyone to yet. Mostly because it's just we're still pushing upgrades to the nodes, and we don't want to be in a situation where people are getting frustrated that the nodes are breaking. But I think we're at a point of pretty serious stability now. So I think over the next few weeks, we will open that up. And at that point, what will happen is there will be basically just a web page on our doc site, which tells you how to run a validator in a node, and you can hook one up. And remember, there's a stake if you actually want to speak and be a validator, if you want to challenge. But the nice thing is that's an on-demand stake, right? So you can just be watching the protocol and never do anything and never put down any stake. And then only once you see something wrong, get involved and put down a stake and say something. And then you have a week actually to do that. So you can say, hey, if you don't have the funds to get a stake, you can amass a stake together or something like that. So basically, yeah, you should look out at our developer docs for information coming there, how to run validators and RPC nodes soon. For now, though, we also have, if you're looking for RPC nodes, we host a public RPC at arbitrum.io/RPC. And we also work with some of the best RPC providers out there, such as Alchemy and Infura and others, and providing RPC services, to give you data from Arbitrum nodes.
Yeah, because I think the security is very important because, yeah, that's it.
Absolutely. And that's why the thing about Arbitrum is, and this is, critically important to us, we don't cut any corners. So we didn't launch our protocol until fraud proofs were fully working and all the code was complete. And similarly, when NITRO goes live, NITRO is in a very mature state, but NITRO will only go live once it's fully complete and is working. And that's the guarantee that we give you, that you can, we take security very, very seriously. And that's the name of the game. So I absolutely agree with you there. Cool. Anybody else? Okay. Can there be any data misalignments between dApps deployed and on the base layer? In other words, can there ever be conflicts? Not really. So the way that Arbitrum, and this is really true of all rollups, operate is they basically look like their own chain. So there is no like, there's a lot of really great work being done in bridging now and saying something, most of it now is just bridging assets quickly between Arbitrum and layer one and other chains. There are also some teams looking at deeper bridging of how we can say have shared liquidity on chain or run protocols that are partially on layer one or partially on layer two. And there's some really great teams that are experimenting with these designs. But for the most part, though, these are really siloed environments, right? So an Arbitrum contract sits on Arbitrum and is secured by Ethereum, and the data is posted on Ethereum, but it doesn't really interact directly with Arbitrum contracts with Ethereum contracts synchronously. The way to interact with an Ethereum contract is asynchronously, where you can have a message that gets picked up from layer one to layer two or layer two to layer one, but you don't have synchronous calls between Arbitrum and Ethereum. So the states are very much siloed. And in terms of like the nice thing about the Arbitrum state is, again, because all data is posted on chain, that's how you guarantee there's never a disagreement by different validators of what the state is. There's always the definitive source of truth, and that's the Ethereum blockchain of what the correct state is. And because everything from there is deterministic, right? The execution of the machine is deterministic. Everything there can be easily validated from Ethereum. And interestingly, and this is one of the differences actually from rollups and Plasma. In some way, Plasma, if you remember from several years ago, was much more ambitious. It tried to take not only the execution off-chain, but also the data off-chain. And it turns out that data availability is a much, much harder problem to solve. So in some sense, rollups like Arbitrum are actually less ambitious in trying to solve an easier problem. But the fact that we put all data on chain is really what allows us to do that very, very effectively. And it turns out that our transactions aren't quite as cheap as the transactions that Plasma was rooting for, but for many applications, they're quite cheap enough, and indeed they'll even get a lot cheaper over time as we push NITRO and other upgrades.
All right, well, thanks so much, Stephen. This is a really good kind of in-depth and technical sort of overview over like how Arbitrum and kind of optimistic rollups work in general. So thanks so much.
Thank you for having me. And again, if I didn't answer someone's question or if something comes up afterwards, feel free to reach out to me. And again, please, if you are on the job market, please do drop us a message.